Today we're going to be solving equations with variables on both sides. So we're going to have the x's on either side of our equal sign. Now remember, to solve an equation with variables on both sides, you may have to use your distributive property to get rid of any grouping symbols that we might have. You have to use your properties of equality to clear any decimals, fractions, to do any adding, subtracting, multiplying, or dividing. You combine like terms if they are on the same side of the equation. We use the properties of equality to get the variable terms on one side and the constants on the other. So you want all the x's on one side of the equation, all the constants, the numbers, on the other side. Then again, use the properties of equality to solve for the variable like we've been doing the last couple days. And if you need to, then check your original equation. So in problem 1, solving an equation with variables on both sides. First of all, the 7k equals 2 should be a 7k plus 2, so we have a typo there. Now notice that you've got a k on the left-hand side and you've got a k on the right-hand side. We don't want the variables on either side of the equal sign. We want them on the same side. So what I'm going to do is I'm going to use my properties of equality. Since this is a positive 4k, I'm going to subtract 4k so that I can get all the k's on the left-hand side. I used my subtraction property of equality to do this. Now on the left-hand side we have 7k minus 4k, which is 3k. Bring down your plus 2. And be careful to bring down your minus 10, not a positive 10. Now we've got all the letters on one side, so I need all the constants on the other. So I'm going to get rid of this positive 2 here by subtracting 2 from both sides. And again, I'm using my subtraction property of equality. So on the left-hand side, we end up with 3k equals negative 12. And for the final step, to get the k by itself, we divide both sides by 3, and we've just used our division property of equality. Remember, solving these types of equations are not new for you. The new stuff is the justifying the properties, which is something that you're going to have to focus on when we're working on the homework. Okay, problem 2, using an equation with variables on both sides, and this time we're going to be solving word problems. It takes a graphic designer 1.5 hours to make one page of a website. Using new software, the designer could complete each page in 1.25 hours, but it's going to take him 8 hours to learn how to use the software. How many pages would the designer have to make in order to save time using new software? Now, normally when I give you word problems, I make you think about them for a while. Because we're doing a special kind of lesson today, I'm going to help walk you through this one. It takes a graphic designer 1.5 hours to make one page. Using new software, he can do it in 1.25 hours, but it takes him 8 hours to learn the software. How many web pages would a designer have to make in order to save time using the new software? So my x is going to be the number of web pages, because that's what I'm looking for. Now, I want to save time using that new software. That means whatever I'm currently doing is going to be greater than, or is going to take more time than the new stuff. Because again, I like to write myself notes about what's happening with the problem. Well, the current time, it currently takes them 1.5 hours for one page, or for each page of the website. The new software, it takes him 1.25 hours for each page, but he also has to spend time learning the software. And I want the current time to be more than the new software because I want the software to save me time. Again, notice I have variables on both sides. If I have a positive 1.25x, then I'm going to subtract 1.25x to get my x's on the same side. When I do that, I end up with 0.25x excuse me, is greater than 8, and divide by 0.25. So I end up with x is greater than 32 pages. Now, it's important when you are working on a word problem that you understand the question. The question was, what's the number of web pages that he's going to have to work on in order to make the new software time saving? But notice our answer says x is greater than 32. That's not the final answer. If the number of pages for the website has to be bigger than 32, then they actually have to complete 33 pages in order for the new software to be more efficient. My answer said that x had to be greater than 32, so the next page after 32 pages is 33 pages. Let's take a look at the next example. Pristine Printing will print business cards for 10 cents each, plus a setup charge of $15. The printing place offers business cards for 15 cents each and a setup charge of only $10. What is the number of business cards? What number of business cards costs the same from either printer? So I'm looking for the number of business cards. So I'm going to let x equal the number of business cards. Now the question says, what's the number of business cards that I have to get so that the cost will be the same from either printer? That means I want Pristine, whatever they're going to charge me, to equal whatever the printing place is going to charge me. The same being equal in math. Well, Pristine charges me 10 cents for each business card, plus a setup charge of $15. The printing place charges me 15 cents for each business card and a $10 setup charge. And I want Pristine to be equal to Place in order for them to have the same number of cards. Again, notice we have variables on both sides. This time, because the 0.10 is smaller than 0.15, I'm going to subtract 1.0x, or 0.10x, from both sides. And it doesn't matter that the variable is going to be on the right-hand side, because it's an equality. We can switch the order of the equation and it won't matter because we're still equal on both sides. I subtract 10 from both sides. And then I divide both sides by 0.05. So when they've printed 100 business cards, I'm going to have the same cost for Pristine Printing and from the printing place. Okay, let's look at the next example. Problem 3 says solving an equation with grouping symbols, our distributive property. When you have a number in front of parentheses, you have to multiply that number through the parentheses, only with addition and subtraction. Same thing on the right-hand side. We've got a number next to parentheses with addition and subtraction, so we're going to use our distributive property. 2 times 5x is 10x. 2 times 1 is 2. Equals 3 times x is 3x. 3 times 11 is 33. Now, if I were asked to justify my steps, I would actually say that I used my distributive property. It's not a property of equality, but it is a property that I use to help me get to the answer. Notice this just becomes a problem with variables on both sides. Since I have a positive 3x, I'm going to subtract 3x. And I used my subtraction property of equality. Since I want all the variables on one side and all the constants on the other, I'm going to have to get rid of that -2 or -2 by adding 2 to both sides. So I get 7x equals 35. That's my addition property of equality. And finally, the last step is divide everybody by 7. So I get x equals 5, and I used my division property of equality. Remember, you are writing out the entire expression, but you can abbreviate the words when you're justifying your steps. Now, it is possible when you're working out a problem, an equation, that you end up with an identity or no solution. What does that mean? Well, no solution is the easiest. No solution means it didn't work. Whenever I worked through the problem, something doesn't add up right. Something doesn't look right. Something's not equal to something else. When I have an identity means that the two sides of the equation are equal. I've gotten rid of my variables, and all x's will work. So if we look at 10x plus 12 equals 2 times 5x plus 6, I see that I'm going to have to use my distributive property on the right-hand side. 2 times 5x is 10x. 2 times 6 is 12. I've got variables on both sides. Since I have a positive 10x, I'm going to subtract 10x on both sides. But 10x minus 10x is 0, leaving me with just the 12 on the left-hand side. And on the right-hand side, 10x minus 10x is also 0, leaving me with a 12 on the right-hand side. Since my variables were eliminated, and this is a true statement that 12 equals 12, that means that this is an identity. What does that mean? That means that every value of x will work to solve this equation. In the previous example we just did, we got x is equal to 5. That is the only x that will make that equation true. But in this example, since we have a true statement at the bottom and our variables went away, that means I can put any x I want into that equation and it's going to be a true statement. I can substitute a 2, I can substitute a 3, I can substitute a negative 20 if I wanted to, and I'm going to end up with what the left-hand side of the equation equaling the right-hand side. Let's take a look at the next one. 9m minus 4 equals negative 3m plus 5 plus 12m. What I want you to notice is we have variables on the same side of the equal sign, which means we just combine them together. Negative 3 plus 12 is positive 9m, and I'm left with a plus 5. Now I've got variables on both sides, so I'm going to subtract 9m. 9m minus 9m is 0, so that leaves me with negative 4 on the left-hand side. And 9m minus 9m on the right-hand side is also 0, leaving me with a 5 on the right-hand side. Now this sentence doesn't make any sense because negative 4 doesn't equal 5. Since I have a statement that's not equal, that means that there is no solution. Sometimes we call this an empty set, and we use an empty set of braces. Now, what's the difference between an identity, one that we just saw, and no solution? No solution means that no value of x makes the equation true. So in the first one on this page, we saw that x could only equal 5. Then the second one, we saw that x can be whatever number I want it to be. In the third example, I can't put any x or any m in and make that equation work. For example, if I were to substitute a 3 in for m, it's not going to be equal on the left and right-hand side. If I were to substitute 100 in for m, it's not going to be equal on the left and right-hand sides. Okay, your homework for tonight is to complete page 106 to 107, number 20 through 40, the evens, 43, 44, and 46. You do not need to check these equations. You do not need to check the equations. However, if you notice on the sideboard, you do have to justify your steps for numbers 22, 24, and 26. So no checks, but you are justifying for 22, 24, and 26. I will be collecting the homework on Monday when you return, so make sure you're showing me all your work. And it's possible to get no solution and identity, so make sure if you do, you label them as such.